Good morning and happy Friday. I apologize for this going out a little bit late. So I'm getting better, but still not where I want to be, or probably not where you want to be. Some of you waking up early looking for something to work on. Hopefully you're working on your facts while you're waiting for this to get posted. Anyway, you know the drill. Copy this down. Come back. Get hints if you need it, or check your answers. You want to listen to the end on this one. Possibility for some free points for what I'm going to call warm-up integrity. Okay? All right, see you in a bit. Back again. Most popular diamond ever. 6 times 7 is 42. 6 plus 7 is 13. And if I do 1 and 6/10, 1 and 6/10, when I go add those, remember you have to line up the decimal when you add, subtract, or compare. Decimal comes straight down, right? I get 3.2. When I multiply, I got 16 times 16. Everybody knows that's 256. But then in order to pretend that was a 16, I had to move the decimal over one spot. In order to pretend that was a 16, I had to move the decimal over one spot. That's a total of 2 spots that I have to go back in my answer. So that's how that works. How about 6 thousandths, 32 hundredths? Hopefully you figured out that 3/10 and 2 hundredths will add to 32 hundredths, right? And then if I go 2 times 3, I get the 6. Here I had to move it over once to pretend it was a 3, and I had to move this one over twice to pretend it was a 2. So that's a total of 3 spots that I have to go back in my answer. What do you do here? Fill in the egg carton. Okay, fill in those zeros. All right, 10 and 6 1/3. If you have done all of the warm-ups the last week, this is easy because it's a repeat. If you haven't, then I hopefully stumped you, right? I want to stump you at least one problem a day. What you do here, though, is go 3 plus 1/3 is 6 and 1/3. And if I go 3 times 3 and 1/3, what do you really have there? Okay, so Mr. Dan, you didn't teach us how to multiply mixed numbers. Generic rectangle comes in great with these mixed numbers, right? 3 times 3 is 9. 3 times 1/3 is 3/3. 3/3 is 1 whole. 9 plus 1, 10. Cool, huh? Yeah. When we start multiplying mixed numbers like 3 and 1/3, 6 1/2, 4 2/5, stuff like that, mixed numbers, using that generic rectangle is kind of handy. All right, the absolute value, remember what that is? That is just how far is that number from 0. How many spots is -6 from 0? 6 spots. We don't care about the sign. We just care how far. The actual value to move it, okay? Whether you're going reverse or forward, up or down. The absolute value of 3, how far is 3 from 0? 3 spots. 6 minus 2 is 4. How far is 4 from 0? 4 spots. 2 minus 6 is -4, right? I have $2. I spent 6. I owe someone $4. How far is that from 0? That's also 4. This is the tricky one. That negative sign is outside of these absolute value bars. The absolute value of 5 is 5. That negative doesn't go away. Negative absolute value of 5 is -5. And negative absolute value of -5 is also -5. This does not go away if it's outside those bars. Okay? Don't be fooled. They will try to fool you. All right. In order to go from a decimal to percent, I just move it 2 spots that way, the decimal. So in order to go from percent to decimal, it's just 2 spots the other way. 40, if I move the decimal over 2 spots, is going to end up in front of that 4.4, 4/10. 4/10 is the same as, I can add zeros, right? 40 hundredths. If I said 40 hundredths and your eyes were closed, you wouldn't know if I said that or that, because they sound exactly the same and they have the same value. If you had a fraction like that, you would simplify it. You would say, well, they both end in 0. 10 goes into the top and bottom. 10 goes into 40 4 times. 10 goes into 100 10 times. And then you would still hopefully say those are both even. I can still simplify some more, because if they're both even, 2 goes into the top and the bottom. 2 goes into 4 twice. 10 5 times. 40%, 4 tenths, 40, hundredths, all simplify down to 2/5. 2/5 is easier to write and easier to draw. All right, I'm not splitting this into 100 or even 10. There's fifths. Let's color in two of them. Less than half, but almost there. All right, 1/6. 1/6 gets tricky. Why? Because when you change a fraction to a decimal, your job is to divide the bottom into the top. And even though it won't fit, you know it will never fit unless it's improper. You add a decimal and a 0. When you go to start dividing, you go 6 goes into 10 once. 1 times 6 is 6. I subtract, I get a remainder, so I'm going to add a 0. And then you say 6 goes into 40 6 times. 6 times 6 is 36. When I subtract, I get another 4. So if I add another 0, I'm saying 6 goes into 40 6 times again. I get another 36. I get another 4. Do you want to do this forever? Some of you maybe. Yeah, we don't have to. We realize very quickly that that is going to go on forever. So instead of continuing to work on this problem without getting much further, I can just write the answer is 0.16, and a line goes over the 6. Not over the 1/6, just the 6, because the 6 will repeat forever. If you put it over the 1 and the 6, then really what you're saying is the answer is 0.16161616, right? Both of those repeat. Only the 6 repeats though, okay? So, what do? I can write this, right, 0.16 and put a line over it. But eventually, especially if I'm going to go to a percent, I want to go ahead and round this. Since I know I'm going to percent, let's go to the hundreds place. Remember the hundreds place is right there. So what you do when you round is you underline what you're rounding to, the place, and then you look to the right. Okay, you want to see, is that a 5 or bigger, right? Excuse me. And if it is, the number you underline goes up by 1. If it's not 5 or bigger, the number you underline stays the same. It never goes down. We say round down because we're chopping off something, but it'll either stay the same, the number you underline, or go up by 1. So again, squiggly equal sign means it's about 0.17, and now, boom, boom, to go to percent, it's about 17%, okay? 1/6, let's divide our pie into thirds, and then let's say, oh, we have some more people to share it with, so let's cut them into 6. You get 1 slice. All right, 120%, move it over twice. I get 1.2, more than 1. Remember, if it's more than 100%, your decimal will be more than 1. If your decimal is more than 1, it'll be more than 100%. 1 and 2/10 is the same as 1 and 2/10. You say these the same, they equal the same. One's a fraction, one's a decimal. Now, 2 and 10 are both even. 2 goes into 2 once and goes into 10 twice, so 1 and 1/5. Simplified, right? There's my 1 whole, right? And another pizza, but I only get 1 slice of that one. I get this whole pizza and 1 slice. That is 1 1/5. Okay? All right, greatest common factor, GCF. The biggest number that fits. Remember, factors fit. Okay? What's the biggest number that fits into both 5 and 15? Well, you can go get all of the factors of 5, which is just 1 and 5. You can get all of the factors of 15, which is 1 times 15 and 3 times 5. All right, so 1, 3, 5, and 15. Which ones are the same? The one's the same. All right, 1 will be going to every number, so you always have a common factor of 1. Okay, what's the next one? 5 is the same. Is there a bigger factor that goes into both? Well, you can't get a bigger number that will fit into 5 than 5. So 5 is the greatest common factor of 5 and 15. How about 8 and 10? Oh, 5 and 7. 5 and 7 are both prime. Here's a secret for you. Okay, if they're both prime, the only numbers that goes into it are 1 in itself. So 5 is nothing else going to go into it. 1 is the greatest common factor of 2 prime numbers. 8 and 10. Some people say 80. Well, guess what? You're thinking multiples right? What number is going to 8? Well, 1 and 8 and 2 and 4. What goes into 10? 1 and 10, 2 and 5. Well, 1's the same, 2's the same. 2 is the biggest one that's the same. The biggest number that fits into both is 2. 18 and 36. Always double check, like on this one. Does the small number fit in the big one? All right, because if it does, then the small number is the greatest common factor. What does that mean? The small is the greatest? Did you just say that, Mr. Dan? Yes, you cannot find a bigger number that fits into 18 than 18. It is the greatest number that fits into 18. And because it also fits into 36, it is the greatest common factor of 36. Here's something cool. I just said that if the small fits into the big, then the small is the greatest. If the small fits into the big, then the greatest is the least. I can't find a smaller common multiple than 36, right? Because I can't get a smaller multiple of 36 than 36 times 1. All right, 36 times 1 is the smallest multiple of 36. It's the first one. When you start doing multiples of 36, you say 36 times 1, 36 times 2, 36 times 3, 36 times 4. Ooh, that's gross, right? You can't find a smaller one, all right? 36 times 5, 36 times 6. Okay, we're done with that. All right. Anyway, that's kind of cool. Now, what did I just say? I said if you have a number that a small number fits into the big one, the small number is the greatest common factor, and the big number is the least common multiple. Well, 5 fits into 15. I said the biggest number is the least common multiple. That's 15. You can't find a smaller multiple of 15 than 15 times 1. Now, here's a rule for you. If two numbers are prime, the least common multiple is their product. You can't find a smaller multiple that goes into 5 and 7 than 5 times 7. 8 and 10 does have a smaller one than 80, though, right? What is it? 40. 80 is a common multiple, but 40 is the least common multiple. Again, multiples. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. All right, and I do 10s. 10, 20, 30, 40, 50, 60, 70, 80. Yes, 80 is a common multiple, but guess what? So is 40, and 40 is smaller. It is less. It is least. All right, you cannot add fractions, subtract fractions, unless the denominator is the same. So the first thing I do here is I rewrite these vertically because I know I have to change the denominators. Now, we just talked about what's the smallest number that 5 and 7 both go into, right? It's 35. So I'm changing these to 35ths. And how did I change the 7 to 35? I multiplied it by what? By 5. So I put a 5 here? No, that's the most popular wrong answer. I have to take that 5 and multiply it by the 2, right? I did 7 times 5. I added 2 times 5. That's 10. What did I really do? I multiplied 2 sevenths times 5 over 5. Well, what is 5 over 5? That's equal to 1. I can multiply anything by 1 and get something that equals it, right? So 10 35ths equals 2 sevenths. Same idea here. I did 5 times what? 5 times 7. So I got to go 3 times 7. And now I have 10 35ths plus 21 35ths is 31 35ths, and that's my answer. Okay? Here I have fourths. This is a cool problem. 2 1/4, and I'm going to subtract 3/4. I don't say 3 minus 1 there. I'm taking 3 away from the 1. I need more fourths. Where can I get more fourths? Well, you're going to borrow from the 2, but here, be careful. Don't just cross out the 2, put a 1 here, and put a 1 there, right? Because that would give you 11 fourths. I had 1/4. I borrowed 1 whole. I shouldn't end up with 10 more fourths. 1 whole is not equal to 10 fourths. 1 whole is equal to how many fourths? Good. If you said 4 fourths, you got it right. So when I borrowed that 1 whole, I got 4 fourths. I already had 1/4. How many fourths do I have now? If you said 5, you got it right. Right? I borrowed 4/4, so now I have 5/4, and I could take away 3/4. 5/4 minus 3/4 is 2/4, and 1 minus is, okay. Now, if you got that and you couldn't find your answer, say it was on a worksheet or something, why do you think that would be? Because Mr. Daniel did it wrong. No, you can simplify. Both of those are even, right? 2 goes into the top once and goes into 4. 1 1/2. I love these. These are cool problems. Wait till you start subtracting fractions or mixed numbers with unlike denominators where you got to borrow. You got to do another step. Anyway, let's do this. And I gotta tell you, you're gonna see these problems. You're gonna see these problems in the future. You're gonna see these problems in the future. We got a test coming up. I'm not sure where you're gonna see them, but you might understand how to do these, right? Here, I know exactly where you're gonna see this one. Where are you gonna see that one? Well, 2 1/4 minus 3/4. Boom, we just did it. 9 3/10 minus 3 4/5 plus 2 9/10. Ooh, looks familiar? Yeah, C47 coming your way next week. If you paid attention, you just got those answers. All right, I have to add these first. Now, I can't add 4/5 and 9/10 because the denominator is different. But I'm lucky because 5 goes into 10. So I'm leaving the 9/10 as 9/10. I'm changing 4/5 to 10ths. 5 times 2, 4 times 2. So 8/10 plus 9/10 is 17/10. That's more than one whole, right? 3 plus 2 is 5. 10/10 is a whole, right? It's 1. So I'm going to use 10/10 to carry and make that a 6, and then I'll have 7 left over. So 6 7/10 is what these parentheses comes down to. I still have to go 9 3/10 to subtract. 9 3/10 minus 6 7/10. Now, I don't like this because you're going to subtract where you got to borrow, but I don't want you to cross this out and put a 1 in front of that. I want you to think I borrowed 1 whole because why? I needed more tenths. How many tenths is equal to 1 whole? 10. How many did I already have? 3. How many do I have now? 3 plus 10 equals 13. Now you're saying, but Mr. Daniel, if I would have put a 1 there, that would have worked. Yes, you could have done it wrong and got it right. I hate those problems. Okay, why would it work? Well, because the fraction's tenths. If the fraction is tenths, you can put a 1 there. But that's the only one. How many other denominators could you have? Infinite, right? So you don't want to say you have infinite possibilities and 1 out of infinity is when you get it right, right? You want to know how to get it right all the time. 13/10 minus 7/10 is 6/10. 8 minus 6 is 2. I can simplify that. 2 goes into 6 3 times. 2 goes into 10 5 times. So this ends up being 2 3/5. All right. Hopefully you learned something. Here is the deal. If you are in Mr. Daniel's class and you email me and the subject line, you write integrity with WarmUp. If you write that in an email, don't put it on the stream, okay, but in an email, and use that for the subject line, I will give you 5 extra credit points because that tells me you watched this video to the end, right? And that is what I want you to do, okay? Not so you get points, but so you have that integrity and you learn more, okay? So type me an email with that. You get 5 extra credit points. Have a great weekend, everybody.